about the history of the calculus. Yeah, so history awareness has an impact on teaching and learning mathematics. It includes knowing the historical development, the question under investigation, and the answer given to these problems. So in this paper, the focus lies on calculus and its application in economics. It also shows how far the knowledge of changing specific understanding can be beneficial in teaching education. So the paper covers the issue from an epistemological, historical, and educational perspective and suggests a constructivist for educational purposes. Yeah. Okay, hi everyone. So today I will present about the introduction. So in the world around us, everything is changing. The mathematics of change is largely about the rate of change, how fast and in which direction the change is occurring. The primary objects of study in differentiate are the derivative of functions. Related notions: the derivative of a function at a chosen input value describe the rate of change of the function near that input value. Yeah, and also the process of finding a derivative is called differentiation. So geometrically, the derivative of a point is the slope of the tangent line to graph of the function near that point, and provided that the derivative exists and is defined at the point. So for a real value function of a single real variable, the derivative of a function at a point generally determines the best linear approximation to the function at that point. Yeah, and also in economics and the commons, we come across many such variables, and where one variable is can be said to be the function of price. Then the supplies and the price can and one such quantity changes with respect to the other. And then the marginal analysis is the examination of the situation where we add on one unit as an independent variable to the system. Thank you.
I want to talk about the method. So why the company need to use the marginal analysis? Actually, marginal analysis is their decision making tool to know their maximum profit. So the company will use the differential calculus to find the marginal analysis and to know the maximum profit and the minimum cost. We want to use the marginal analysis. Actually, the company use the marginal analysis is as the decision making to maximize the profit. Yeah, profit. So how we find the marginal analysis? Of course, we use the differential calculus to know the minimum cost and the maximum profit. In marginal analysis, usually we will be asked for find two things. One is the estimate how much the profit, revenue, and cost when n unit is produced or sold. The second is exact amount of how much profit, revenue, and cost change. So we now want to know the estimate how much of profit, revenue, and cost. We will use the differentiation. For example, we know we have the n. This means the cost function. So we want to find the marginal analysis. We will use the differentiation and become the C prime S. Is such nth unit is produced inside the C prime. So we will know the cost of the nth unit. Now to find the how exact amount of how much profit, revenue, and cost change. So we will use the Fn minus F n minus 1 to know the at the amount of the N.
Now I'm going to explain for the example 1. For the example 1, the question given us two equations. For the first equation is cost function, and the second equation is revenue function. So the question 1 requires us to find the profit function. For the profit, we use the revenue function minus the cost function. We will get this equation, this answer, negative 20,000 plus 175x minus 0.175 x squared. Question 2 requires us to find for the marginal cost, marginal revenue, and marginal profit. For the marginal cost, we use the cost function and differentiate it, and we will get the 25. For the marginal revenue, we use the revenue function and differentiate it, and we will get 200 minus 0.35x. So to find the marginal profit, we use the profit function that we find in the first equation, and we differentiate it, and we will get 175 minus 0.35x. For the question 3, we are required to find the marginal function when x equal to 400, x equal to 500, and x equal to 600. So we just put the 400 into the marginal profit function, and we will get this 35. So this means that at the production level of 400, the profit increase at the rate of 35 ringgit per unit. So when x equal to 500, we will get 0. So this means that at production level of 500, profit remain constant and unchanged. So when x equal to 600, we will get negative 35 ringgit. So this means that at production level of 600, profit decreases at rate of 35 ringgit per unit. Now I'm going to explain for the example 2. Based on the question given, let x equal to the number of set ordered in excess of 60. So the number of sets ordered is 60 plus x. So price per set is 700 minus 10x. Question given, we are required to find the revenue, maximum revenue. So to find the revenue, we need to find the revenue function 60 plus x times 700 minus 10x. So we differentiate, and we will get the revenue, marginal revenue, and this will be the result 100 minus 20x. So when the marginal revenue equal to 0, we will get x equal to 5. The second derivative to determine whether that the revenue is maximum or minimum. So for this question, our second derivative of the revenue function is negative 20. It is smaller than 0. Therefore, we can conclude that it is maximum revenue, and the largest size of order is 65.
Conclusion for the two examples. This project is about how the derivative apply in our daily life, especially help to solve the problem in economy area. Based on the result for the two examples, we understand how the differentiations applies in the economy and the benefit of the marginal analysis can maximize the profit. In a marginal analysis, use the formula of differentiation to determine the marginal cost, the marginal revenue, and the marginal profit, and determine the actual cost and quantity could able to help company to determine their budget and proposal. Furthermore, we could also determine the marginal profits and the extra cost of the production on more items for the break-even graph.